Namaskaram. This is Nagarajan. Glad to meet you all once again. Hope my voice and video are clear to you. If so, can someone give an emoji or raise the hand? Okay. I think I could see one hand raising. That's good. So let us start it. So far, in the last 2 weeks, in about 6 classes we did a mixture of physics, chemistry, biology, some maths, and English. Roughly about 30 to 35 activities are done. So far, this 30 is a sample. There are totally about 300 or even 500 such activities. Once again, this capacity building is not to teach the concept, because you as a teacher already know, you are an expert in the respective subjects. The aim is how to use these tools to make it simpler and interesting. That's all. I re-emphasize that once again, because a few queries came, this concept we already know. Yes, you already know. You know the concepts behind Ohm's law or focal length of a lens. Everything as a subject matter expert, as an experienced teacher, all the teachers know. But how to use it using a simulation or an activity based content. That's what we are trying to do. Now let me start showing my screen. I am going to present. I hope you are able to see my screen. Digestive system. The first thing that I want to show, this is a 3D model. Okay, I can go inside this. I can enlarge it just by using the mouse crawler. I am doing it in 3D model. Now I am using my mouse to turn to left or to, and then turn to my right. Okay, so actually this is the right hand of that person, whereas for me it is the left. So I can simply turn and see it from the back. If I see from the back, I'll just enlarge it, right? And I can move it. Now I can bring it best. From the side, how will it look? From here, how will it look? Everything you will be able to see. This is like typically in schools, you already may have a model, a physical model with the whole stuff, so that people can touch it and then feel it. But usually it may be either in wood or sponge or thermocol, sometimes fluffy material like rubber or soft rubber. But this one is a model. It's in 3D model, so it gives the complete digestive system. So if you want to teach it, of course we will draw. At the same time, we can also give it, show that what are the typical parts of that, right? And again, since this is taken from an American site, you would see some of the spellings in American mode. Okay, don't worry about that. For example, if I take mouth, right, it highlights only that part, right? and then it shows that. Okay, so how does the mouth look? So I don't know how to see at the back of the mouth, but now by moving my mouse, this is what I could say. This is how the mouth is located from the front. If you look from the top, this is how it will look. Behind that, the pipe goes, right? So I can move it, and then I can resize that. I can reduce the size. So I will be, as a teacher, I will be able to show part by part. For example, then the tract, okay? Or say, now I say stomach alone. I bring it down, I increase it. So now this is the area where soon after I eat, the food will come and get stored. Then I can say duodenum. So this is the part. This connects stomach to the next level of digestion. This is a small part. Now it goes through, of course, there is a liver. Now we will be in a position to say to the people that compared to the size of the stomach or duodenum, liver is bigger and gallbladder is close to the liver. It is almost attached to it, right? We will be in a position to show that. Now we can say, since I am not able to see the gallbladder from the front, I am turning it like this. Okay, this is liver, this is gallbladder. Each one has its purpose. So gallbladder is close to the liver, sorry. And then there is a color coding. Typically, people might have seen gallbladder stones, right? So gallbladder also can develop pretty much like we get kidney stones. Gallbladder also gets stones. So we can now show this is just behind the liver. Now I'm bringing back to the front. Now I want to show pancreas. So pancreas is the one from where we also get some secretions to be part of the digestive system. Then it goes to the small intestine, right? It goes to the small intestine. So small intestine is having a lot of curly stuff, and then it is the one that absorbs a lot of stuff from our food. So the digestion happens right from mouth. Some amount of digestion happens. But to absorb all the material, it has to go through the small intestine. Now, if I go to this is the area where we say large intestine, and then the colon, and then the rectum part. Now what happens is, this is not having a lot of spirals, but it goes like this. Now I can also show, if I go here, there is a small part. Sometimes people used to get this appendicitis. When stuff goes to this part has to be removed, otherwise they will get a lot of pain. We will be in a position to show exactly what happens, and then how it gets finally excreted out of the body. So the complete digestive tract through which the food goes through, and then the vitamins, water, everything gets absorbed. The energy gets absorbed from the food, and then how, including sugar, everything, minerals, sugar. We will be in a position to show this to the students. So this is a complete digestive system. So this is just one system in our human body. Traditionally, we used to show, I stop my screen, I come back to the video. Traditionally, we will show either through a picture hanging on the wall, or we draw or we have a physical model depending upon the school infrastructure, then we show that to people. This can be shown to anyone. This can be shown via the projector or the IFP or from the tab, worst case from the mobile also. One good thing is I can enlarge and then see. And then I can turn to the left, turn to the right, move to the top, go to the bottom. I can see everything. So this is one advantage of this simulation. Second thing I want to show is that the same thing, so far we have seen the just one system. Now let me show you one more system. Okay. I think recently in one of the classes, one of our teachers took this, maybe which grade I don't know. They have shown this to the students. Now there is a there was a question asked, are these sites free? Yes, most of the times we will be using .org or .gov kind of websites, because these are all free and open source websites for as a service. If we don't have to pay anything to them, most probably or normally we don't get advertisements also from these. There is no advertisement usually we see. Okay. Now there is an image that is shown here. Now I want to see only digestive system, right? If I move this, it will show in light color. Then if I go to that, it shows in dark color. So in the whole body, this is how the digestive system is located. This is where it is located. Now I want to know respiratory system. I move this. This is called simulation or activity based, because it doesn't just like that play. We need to do something on that, then only it will show or display. If I want to know respiratory system, yes, this is the respiratory system. So you have got the windpipe coming here, you have the lung here, you have the diaphragm here, right? Now I want to see both digestive system and respiratory system. Now you can do this way. Okay. Now from the front, if you look at it, this windpipe is seen, whereas the foot pipe is here. So it is slightly, it is behind. And this particular simulation doesn't have the turning capacity. So I don't, in this one, I don't have a turning way, right? Now, in the whole thing, if I want to show cardiovascular system also, right? Suppose I want to stop this, I don't want to show respiratory system, cardiovascular system. The cardiovascular is, heart is the main part. From here, we are sending the blood. So one type of vessel takes good blood, other type of vessel brings back the blood which is lacking some oxygen content. Again, it has to go through the respiratory system to get more oxygen. So it is coded blue and green. Now I can say here is the heart. From here, the blood vessels go all the way to fingers, and then it goes to, there is a main, these two are the main ones that takes from heart to the lower limbs and the to the hands. This is going to the head. Now we can say, so these are all the ones like typically like in a river. Initially it will be broad, then as it reaches towards the tail end, it will be getting smaller, and then it will be having a lot of branches. It's almost like our Krishna Delta or Godavari Delta or Kaveri Delta. Initially one main thing comes, then it branches out. So I will be in a position to show the entire organ system. not just one system, because we have digestive system. I want to show skeletal, all the bones. So how the bones are located, where the bones are located, what will be the size of the bones. So I can show ilium, ischium, right? Radius, ulna, and then the rib cage, collar bones, then the lumbar, all these things, thigh bone, everything we will be in a position to show. I want to show the muscular system. Okay, this is how the muscles are located. So you have got neck muscles over here, chest, shoulder muscles, then abdominal ones, then the thigh, then the arms, right? And then what typically it will also show the shape of the muscles, because it has to contract and relax. So this is the way typically we will be in a position to show the system. Now, limbs, where are the important secretions happening in our body, and we can talk right from every single lymphal nodes. We will be in a position to show that. So again, this is another way of representing the teaching as a teaching aid. Now I stop sharing my screen. I come back. So far, this is again in biology. Okay. Now, what I would like to ask you is, how many of you already started using these activity-based content in your classrooms? If you can raise your hands or send it in chat, that will be great. I could see one hand, already one hand is raised. If you have already started using these tools, please raise your hands or please respond in the chat box, Q&A, question and answer box. Okay. There are about 85 to 90 teachers are already attending this. I could see only 2 or 3. And I would also like to know, we will also tell the officials, is there any infrastructure problems in accessing these things? Again, it may be internet, poor internet, or it may be power. Just, I don't want to, because I am not the authority. I just want to pass on this information to the officials. Do you have any infrastructure issues in terms of accessing this content via internet in your place, respective place? If so, please just raise the hands. If that number is more, obviously we have to have a report to the authorities. But do you have infrastructure issues, especially internet issue, in your respective schools to access these content? Yeah, so far there is no hand raising. That's good. That's very good to know, because this doesn't need a very thick pipeline or very long, very high bandwidth. You don't need. You don't need a high bandwidth internet. 4G should be fine, because once it is loaded, then it is very easy to access. Okay. Now, the next thing I want to show is from physics. Sorry, I will take chemistry. So far, I have taken one in physics, biology. Now I will take from. Just give me a second. I will start sharing my screen. This is chemistry, balancing the chemical equation, reactions, right? Now I'll just take, it's very simple. It's not like all the equations are solved, just to give a feel to the students. It says 0 N2 plus 0 H2 leads to 0 NH3. So this is, I want to balance it. And there are different ways. We like all the modes. First, let us do this way. Suppose I say 1 N2, okay, and then I increase it to 1 NH3, right? Now it shows this molecule is ammonia molecule is 1 NH3. Nitrogen is shown in blue color. Suppose I say two hydrogen atoms in white color. Here there are 3. So what should I do? I want to balance this equation. Okay. Either I can see this way, count 2 nitrogen, but there is 1 nitrogen here. So I increase this 2. So here there is a 2 nitrogens are here. Now I say 3 oxygen, 3 oxygen, 3, sorry, hydrogen. 3 plus 3, 6. So if I increase to 2, 3, then you say it's balanced, correct? Now it says balanced. Till then, I don't get this smiley. Suppose I decrease this. Now it says, no. You have got 6 hydrogen atoms over here, and then there are only 3 hydrogen atoms over here. So it is not balanced. This is one visual. Now I have another visual, like a balance. Suppose I do like this. It's like a balance. So nitrogen atoms, hydrogen atoms. I made it to 1. Suppose I made it to, okay, nitrogen is balanced, hydrogen is not balanced. So this balance shows the student, okay, nitrogen I don't have to change anything because 2NH3 already 1N2, this is balanced, so this is coming clean, no issue, this balance is done. Only hydrogen has a problem. Hydrogen has 6, this side right hand has got 6, left hand got 2. So what should I do? Study 2, 4, 6. Now this is balanced. So this is again, typically it's all multiplication. 3 into 2 are 6, 2 into 3 are 6, 2 into 1 is 1, 1 into 2 is 2. Sorry, 2 into 1 is 2, 1 into 2 is 2. So that is a fundamental mathematics behind it. But when we show it like this, it becomes very interesting. Now, water, H2O, I move to H2O getting separated to hydrogen and oxygen. Now I increase oxygen to 2. Now I increase hydrogen to 2. Now I increase this 2. So the moment I increase either up arrow or down arrow, hydrogen is balanced, oxygen is not balanced. So what should I do? Here there is 2. Now I increase this. Oh, now oxygen gets balanced, hydrogen is not balanced. So left hand side I have more, right hand side I have less. So all I need to do is, let me try to increase this one. Yeah, this is done. So 2H2O leads to 2H2 and 1O2. Same way I go to another equation, combust methane. Methane plus O2 leads to CO2 plus H2O. Now I want to balance. Previously we were dealing with only 2 elements, nitrogen and hydrogen, and hydrogen and oxygen. Now here carbon, hydrogen, oxygen, 3 elements are involved. So I want to show, let me just randomly increase. Okay, now I see 1 CO2. Suppose I increase this one. Okay, again this is done, and I increase this. Oh, I randomly did something without even applying my mind. Now I have done this way. Now I increase this one. Okay, now it says 1 CH4. The reason why I was able to do without even thinking way too much, you can also ask a question. No, we should think. Yes, we should think. But before the kids thinking, we should get them interested. We should grab the interest first. When the interest comes, thinking comes automatically. To grab the interest, make them play. This is like playing the games. So I did literally played, right? Now when I did this, 1 CH4 plus 2 O2 leads to 1 CO2 plus 2 H2. So this is what the balanced equation comes. So this is again another simulation that helps to start with the basics. There are advanced level software to even balance very complex inorganic or organic equations. Okay, I stop the screen now. I come back. Now I am going to start a poll. So far, we have seen two simulations. I am in fact three, one in the digestive tract alone with 3D models, and another all the organ systems of humans, and another in terms of balancing a chemical equation. Okay, now I have published a poll, so you can answer because this is typically the way in online we can engage, and I will also suggest people to write back. We are open. You can scold me, Nagarajan. No, this is not very interesting to me. No problem. So I will improve. I just want inputs from you. More inputs. We can fine tune the methodologies of delivery. Okay. Good. So once I reach 20 votes, then I will stop poll, and then we will. So far we have got 18 votes, and 20% of people answered. Still okay. There's no more votes coming, but I will publish the result and then stop the poll. Okay. So 94% answered, means 17 out of 18 people who voted said very much. One said neutral. Fine. Now we will jump into physics. You have seen biology, you have seen chemistry. Now we will see physics. Just give me a minute. See, this is in software. This copy paste is an amazing stuff. I have to copy paste my URL here. Okay. Without copy paste, I cannot imagine the world anymore. That is the biggest help that we are getting from software. Now I'm showing the screen. I come to physics. Now I want to show something about the density with the help of buoyancy. And all of you know the fundamental Archimedes principle. That typically in a fluid, I have water over here. Whether the substance will flow or not, whether the object will float. Will it float or will it sink? Or will it do something like half, like this? So what is the reason for the substance to float? Again, Archimedes found it. If it is displacing more, then it will start floating. If it is not able to displace more, it will sink. It's a very, I'm talking about in a very layman's view, but science definitions will be further refined. Now it is wood. This is water. This is wood. Okay. So you got 102 liters of water. Now this wood mass is 2 kg. Okay. But the volume it is displacing is 5 liters. That is why it is floating. It is displacing more water. Right? 5 liters of water is 5 kgs. Now I change this to PVC. The PVC material now has got the mass is 7.2 kgs, but it is displacing only 5 liters of water. Okay. Suppose even if I increase the volume, right? When I increase the volume, it is not able to displace that much. So it is sinking. Next thing, let us take foam. Foam, it is only, and you can say mass by volume, right? Typically your calculations, you can say what is the mass by volume, that will be the typically your density. Now this has 0.6 kgs only and the volume is 4 liters, so it is floating. Why we are choosing water? Because water 1 cubic centimeter, or say that is the basis for defining the density. Now I take ice, or say brick. Brick is again, its mass is 8 kg, but the volume is 4 liters, so it is not floating. And this is the density level. 8 different mass divided by volume, 8 by 4 is 2. Now I take, of course, aluminum is a metal. This metal, its weight is this big. Now next thing, let us take ice. Ice is one interesting stuff. As you know, typically the same element in gaseous form and then in liquid form and then in the solid form. Ideally, the molecules come closer from gases to liquid to solid. Ice is the solid form of water. But why it is floating? Ideally, it should sink, but it is floating because there is a tendency. You might have noticed in fridge freezer, we pour water in the tray and then make it freeze. If it contracts from liquid to solid, if it shrinks in size, if it contracts in size, it will fall from the tray. Instead, even if I turn it upside down, the ice doesn't fall from the tray because the volume has slightly increased. This is why ice, especially water, it has a tendency, when it freezes, it slightly expands. That is why the mass is only 3.68, whereas the volume is 4 liters. When it is actually water, it would have been 4 liters of water. Okay. But that 4 liters of water expands when it freezes. That is why ice from the freezer tray doesn't fall. At the same time, in poles and in highly hilly areas, the rocks are breaking because the water goes inside the cracks. It freezes, it expands slowly. It happens for millions of years. It cracks. So ice is a very special thing and it floats. Unlike foam, it floats with slightly only if it displaces this amount of water, for the remaining volume, it is shown on the surface of the water. So this is all again why it is floating. That is again typically Archimedes principle. And what is the density? Mass by volume. We are able to show with metals, brick, wood, foam, ice itself. So this is another experiment I wanted to show to you in physics. The next one I want to show, it is not physics or chemistry or it is on aptitude building, because we always insist. Let it load. I am waiting. We always insist that analytical reasoning is very, very important. We should give some means, some method, some path for the students to think. Getting them to the original thinking mode is very, very important. I would say more than learning, okay, a plus b whole square or Pythagoras theorem will give us the academic experience. But analytical thinking, if that comes first, rest everything will follow. This is typically to give exercises to the brain. Okay. Let me show. Let's first take this one itself. This is like a tunnel. This is a transformation. Okay. Left hand side, I have some objects. Once it enters the tunnel, I do a transformation. How will it apply here on the right hand side? A simple thing I'll show you. This is like, it does nothing. It's a hole, it just passes through. So I take this and then put it here. Now it just turns like this. The transformation you see here, the footprint looks like this. It is turned 180 degrees like this. It's like a mirror reflection. So this is a mirror reflection. Now I say, I put this guy, right? It is reflected like this, mirror reflection, right? Now let me reset it. Okay, let me reset it. Now I put this transformation. It helps people to start thinking. This is only 90 degrees rotate. So if I put this one, how will it look? So 90 degrees. So we are not asking the people to draw, but this is here. I am rotating by 90 degrees. How will it appear? Understand. See, visually understand. Second thing, I put it here. This is symmetric. So I don't see a difference at all. Now I take this butterfly. Butterfly comes. So this is rotated by 90 degrees. Now I take this person, rotated by 90 degrees. Correct? I have some more objects. I have this cherry, sorry, this beaker, conical flask. Conical flask is rotated by 90 degrees. I have this cherry rotated by 90 degrees. Now, this helps children to start developing visually how I see, oh, because the brain, human brain is wired. Human brain is already trained to understand the visuals better than the text. That is why young kids, especially in the first 3 years, they learn so many things, seeing so many people, seeing so many objects, seeing so many colors, patterns. They learn. So this is one thing that helps to show how this happens. Now, going one step further. This is one transformation. Now, I can have up to 3 transformations. Let us do one thing. First, rotate it by 90 degrees. Again, there are more transformations here, right? Change the color, right? And compress it, erase it, something like that. Now, there are so many transformations here, of which I am choosing, okay, 90 degrees turn, and then do a mirror reflection. Do a 90 degrees, and then do a mirror reflection. How will this guy look? Help the students to understand. So first he goes through that. I'm just dropping it. He goes through 2 things. One is 90-degree reflection, rotation, then a mirror reflection. Now I take this 90 degrees changing and then a mirror reflection, correct? So this makes sure that, whereas if I put this one, we will not be able to see the difference because it is symmetric on all sides. Whereas I take this guy, right, 90 degrees and then do a mirror reflection. So this comes. So this is typically a way that we can tell the students how this happens. Now, one more thing I'll just finish. I'll just take this one. This will remove the color. It shows in black and white. So now I take this. This color is removed out of this image. I take this blue guy removed out of the blue color. Now I take this black and white. There's nothing to remove, so it comes as it is. Where does it help? Visually compare left hand side and right hand side. And what is the transformation? This is very basic because there is a magazine, CSR. I just stopped my screen. Anybody has seen this or studied this? Many people would have done this. CSR, Competition Success Review. I'm not sure whether it is still coming. You used to get it as a book. Competition Success Review. That has only aptitude questions and analytical reasoning questions, UPSC questions, all standard competitive examination questions. Why? Because it is extremely important that people develop aptitude, thinking ability, right? Now, I want to show one more thing under aptitude. This is it. Let me start showing the screen. The other day, I have just touched scratch.mit.edu. Okay. Now, I go to create. When I go to create, the other day I showed a few games, hide and seek game kind of games. Now, if I go to create, it helps people to understand this is the original state of the image. When I give some instruction, how will it look like? Okay. See this. Okay. There are on the left hand side, motion, looks, sound, events, control. This is completely, if you are able to master Scratch, you are ready for programming in software. Now, because programming in software is nothing but step by step instruction. It is like mathematics. We do derivations in mathematics. Software is nothing but deriving from top to bottom, splitting bigger task to smaller task. First thing, I click here. The moment you click here, you could see this image. Now I click move 10 steps. I click here. It moved. Okay. I click now. I click on the center one. I say move 40 steps. Okay. Now it moves further. Now I click this. Now what I can do is I can drag and drop this guy anywhere. Right. I can drag and drop. Now watch. I give another instruction. Turn 15 degrees. Click. Turn 15 degrees. Turn 15 degrees. Turn 15 degrees. Now in opposite direction, turn 30 degrees. Okay. Turn. First, kids, don't worry whether this kid is in 4th standard or 3rd standard or 12th standard. Kids are very, very smart. If we slowly explain in a nice manner, what a 12th standard student can understand, even a 3rd standard student can understand. This we have proved in so many times. So it is up to us to tell these tricks to these people. Now I move it to turn 15 degrees. So turning to the right hand side clockwise, turn it anti-clockwise. So what I did is moving, turning to the right and turning to the left, right? Can I give negative numbers? Move minus 50 steps. Okay. So it is moving in a different direction because it is walking towards this direction. And then I'm saying moving minus, then it goes backwards. Positive or negative also we can see, right? Now I would say go to some random position. I don't know which position. Randomly go somewhere. Go to some random position. It is when I'm not able to pick which position, but you choose randomly as your mind says. It moves to the random position. Now turn it, turn it, turn it, turn it. This is very important. In fact, I have personally told many college students to go to scratch and then start doing it. Many people ask, sir, this is too simple. Doesn't matter. You have come to the college after spending 17 years of your education. After finishing 12th, you have come to the college. Spending 1 week extra is not going to make any big difference in your life, but it is going to make a very big difference in your understanding. Don't think this is too simple. Don't think this is too trivial. Okay, I have come to the college. This is not for me. This is for kids. No. When it comes to fundamentals, we are very clear. You spend 1 or 2 days extra, sky is not going to fall on your head. But it makes your foundation very, very strong, lifelong. This is a very important message I would like to give to the teachers because we are building the next generation, making the foundation very strong in every single moment. This is extremely important. So what I am going to do now is I am passing on. I stop my screen. Okay. I stop my screen. In the chat, I am giving the URL. Okay. You please try. There is one suggestion that came. Try to allot time for one subject a day. We have suggested that, but the thing is, we have a lot of teachers attending from different spectrum. That is why, especially when it comes to even up to 10th standard, 8th standard, definitely, these subjects are quite common. And it's not like though physically in a classroom, a math teacher doesn't take science, but it helps a lot. It helps a lot in terms of competency building across the teachers. Okay. So that is why we are clubbing, since maths teacher, science teacher, and English teachers are all again within science, physical science, and biological science teachers are attending the same group. We are taking it so that everyone can have a pie. And again, it is not hard and fast rule. It is not like can the college like, oh, I will take only mechanical engineering, something like that. This is quite common. Since you are closer to the students, you can impress in so many things. That's why I have sent the URL to your Q&A box. You open it, please try it out. I would like to wait till you try. Okay, try it out. See whether you are able to rotate that image. All I did is move, rotate, randomly move, turn. Right? A few instructions. There are more instructions. You can build a complete story out of this scratch. Take it from me. This is the fundamental of computer science. If anyone wants to, and computer science today, giving step-by-step instruction is inseparable to any department. I am a mechanical engineer. I should also know computer science. I am a chemistry research student. I should also know computer science. I am an aerospace engineer. I should also know computer science. I am a mathematician. I should know computer science because computer science is nothing but pure logical thinking, nothing beyond that. Pure logical thinking, like electricity is common to you and me, like WhatsApp is common to you and me, computer science is common to everyone. For computer science or for any competitive exams, basics are analytical reasoning. Okay, I have passed the URL to you. For the next 3-4 minutes, can you please try it out? After trying it out, I will wait. I will stop my recording. So we will be giving coaching to you to build your own scratch material. We'll be giving coaching to you your own scratch material, word wall material, so that you can create some material which is very useful to you over and above what are the materials already available as teaching aids, right? Good. That is the reason why we are now we have come 2 weeks now. We'll be slowly moving, yes, at a little bit faster pace. Aim is to make sure that each one of you is competent to use these tools so that you can explain through this digestive system or solar system or electric circuits, so that the 40 minutes class can be reduced to 20 minutes, and then you can discuss more with the students and make it practical, make it activity oriented. That is the fundamental aim. Reduce the time, increase the interest, make it completely activity based. Okay, that's the aim. Okay, so with that, any other feedback? I just want to close the session today. Any other feedback that you want to give? We'll wait for a minute. You can type it in the chat box. So thanks for the answers in the polls. We'll meet again tomorrow, and I don't see any comments coming in the Q&A box or in the chat box. So thanks a lot. I'll stop here. We'll continue tomorrow. Jai Hind.